Here, we're going to use the strategy of completing the square to evaluate the integral. We'll also rely on our table of integrals to help us. So in the video preceding this, I showed you a table of 20 integrals. As I mentioned, your textbook has access to that table of integrals. Sometimes your homework will reference you to a table of integrals, your online homework. And so I just want you to be aware that there is a table of integrals that you may need to access while you're starting to work on some of these integration problems in this second unit in Calculus 2, Techniques of Integration. So here, the instructions tell us we're going to need to complete the square. So we're going to take this radicand under our radical here. And we're going to use a strategy to make it look like a perfect square minus another perfect square. And the reason we're going to do that is because we looked at our table of integrals and we see an integral that looks similar to this. So let me pull that picture in. Here you see an integral that looks similar to what we're given. One thing you want to notice is we have a difference of squares, some constant squared minus a variable squared under my radicand. So let me shrink that and move that up here off to the side. We're going to be using that a little bit later. Right now though, 8x is not a perfect square. So I'm going to take just that piece, the 8x minus x squared. I'm going to look at rewriting it. 8x minus x squared. Well, I can factor a negative out. That would be negative x squared minus 8x. And we want to look at completing the square. So that means I want to add some magic number to make this a perfect square trinomial. The way we do that, or we determine that magic number, is we always say, well, we're going to take this value b, negative 8, divide it by 2, b divided by 2, and then square it. So negative 8 divided by 2 is negative 4. Squaring that, it's going to give me 16. So I have negative x squared minus 8x plus 16. However, I'm not allowed to just add a random number. The only number I'm allowed to add is 0. So I'm going to write plus 16 minus 16. So I haven't changed anything other than the way it looks. If I consider just distributing this negative to this 16, that's going to give me negative, I have the quantity x squared minus 8x plus 16 plus 16. So what we notice about this is we can factor. What we have here in the parentheses, x squared minus 8x plus 16, factors to the quantity x minus 4 quantity squared. So this is negative x minus 4 squared plus 16, or rather 16 minus the quantity x minus 4 squared. So my radicand, what I have under that radical, can now be rewritten. And I'm going to take this and say, all right, well, I have 1 over the square root of 16 minus x minus 4 squared dx. So now if we zone in and compare that, what we have here, to the integral from our table, we see we have a constant squared. 4 squared gives us 16, and a variable, x minus 4 squared. So I'm going to use a little bit of color when I rewrite this. I have the square root. Remember, 16 is 4 squared minus x minus 4 squared. And that might help you see a little bit better how this relates to that integral from our table of integrals. I'm going to clean this page up a little bit. At this point, examining what I had written or rearranged, I did some careful manipulation to make it look in this manner. I should be able to see how it aligns with the information from the table of integrals. And what we can see is now this is very easy to integrate. This becomes the sine inverse of my x value is actually x minus 4 divided by my constant or my a value, which is 4. And because this is an indefinite integral, we write plus c at the end. So that's just a basic strategy, sometimes how we can use completing the square inside an integral to help us.